All right, let's get started on 3.2. So predicates and quantified statements part 2. So basically an extension of 3.1. So it's more like one long section. Anyway, I wrote the definitions. Let's go through those first. So the negation of a statement of the form for all x and d such that q is logically equivalent to the statement of the form there exists an x and d such that not q. So in symbols, right, which is what we're going to use mainly, negation of this statement for all x and d such that q is equivalent to there exists an x and d such that not q. Okay. Now the opposite is also true. So if we negate a existential statement in 3.2.2, if there exists an x and d such that q of x, this is logically equivalent to a statement of the form for all x and d not q. So that is to say, not this existential statement, not there. So there exists x and d such that q, the negation is the same as saying for all x and d, it's not in q. You see how they're the same? So in the next few examples, we're going to do negations of the statements. Okay. So for example, part A, negate the quantifier or quantified statement. So for all primes in P, right? So for some x element of P where P is odd, what is the negation? So the negation would be this type, right? Or the first one, sorry. So negation would be there exists a P put it in English here. There exists a prime P such that P is not odd. Let's do another one, part B. Let's say there exists a triangle T such that the sum of the angles of T equals 200 degrees. Okay, so the negation would be, let's see here, right? Would be this one here. So for all triangles T, such that it's not equal to 200, right? Not. So let's go ahead and write that. So the answer would be for all triangles T, the sum of the angles of T does not equal 200 degrees. So the first few questions on your homework, all you got to do is negate the statement, whether it's in symbols or in English. Okay. Some more examples here. Okay, this next one, they don't use any symbols. They just say all computer programs are finite. So we can say like for all X computer programs in D, they are finite. So the negation would be there exists some computer programs that are not finite. But if we use just plain old English, right, this will be, well, you can answer in a couple of ways since this is just, English. You could say there is a computer program that is not finite. Or you could say some computer programs are infinite, right? Same thing. Part B, some computer hackers are over 40. So the answer would be the negation. So you could say all computer hackers. But instead of some, you say all. It's the negation of the universal statement. There exists a computer hacker for all computer hackers. Right? You see where we're going with this? All computer hackers. If we say over 40, the negation of that would be less than or equal to. So are 40 or under. Okay. Now let's write some definitions. Okay, so now I'm going to do conditional statements. So negation of a universal conditional statement. So if you have for all X, if P then Q, the negation of that will be there exists an X such that P and not Q. So it's similar to the negation we talked about a couple of sections ago when we first did conditional. We did P arrow Q is equivalent to P and not Q. Logically equivalent. Okay, so let's do an example. Negating universal conditional statements. So part A, for all person write that better. For all if P is blonde, then P has blue eyes. Okay, so the negation, the answer would be, right, there exists a person P such that P and not Q. So that would be, let's see here. P is blonde and does not have blue eyes. That would be the negation. So you would say there exists a person P such that P is blonde and P does not have blue eyes. So there is my not Q right here. Okay, so we went from a P arrow Q statement to a P and not Q from back in 2.2, I think. Okay, so let's do a new definition and then an example, like usual. Consider a statement of the form for all x and d if P then Q, right? P of x and Q of x. Number one, to write the contrapositive of this original statement, you're going to have for all x and d, if not Q, then not P. It's very similar to before, except we have universal statements or quantifiers. Number two, its converse is the statement for all x and d, if Q, then P. Number three, its inverse is the statement for all x and d, if not P, then not Q. So we have to write all these for the this next example. So I'm going to take this statement and write the informal, contrapositive, converse, and inverse. Let's do the formal first for sure, formal and informal. So let's say we change this into quantifiers. Let's see here. Yeah, so the symbolic version would be for all x in R if P, right? If x is greater than 2, then x squared is greater than 4. Which makes sense. It's a true statement, right? Okay, so contrapositive, so the contra in symbols, I'm going to stick with the formal version, is going to be contrapositive would be for all x in R, right? We switch and negate, so that would be if x is less than or equal to 4, then x is less than or equal to 2. Right? That makes sense. Converse. Converse would be you switch them but don't negate them. So this would be for all x in R, if x squared is greater than 4, then x is greater than 2. And the last one, the inverse, is you negate them but don't switch them. So for all x in R, if x squared is less than or equal to 4, then x is less than or equal to 2. So this is what I expect when they say informal in the homework, just write them this way. The informal would be just putting it in English. So I'm going to skip that step here for 3.2.5. But don't forget that the conditional is equal to the contrapositive. We talked about that in 2.3, I think, or 2.2. Okay, this will be the end of section 3.3. 3.2 rather. So the only thing I want you to review at the end is necessary, sufficient conditions, and only if. So the definitions are right here. So for all R, the sufficient condition for S of X means for all X, if R of X, then S of X. For all R is a necessary condition for S of X. That means that for all X, if not R, then not S. Or you could say if for all X, if S, then R. That's also fine. So this would meet the requirements for necessary condition. This is for sufficient, and the only if. So if not S, then not R, or if R, then S. So if they ask you about sufficient, necessary, or only if, these are the requirements. So for homework, just do 1 through 35 odd, and I'll post these notes very soon. And tomorrow, hopefully I can post 3 as well.